Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hey y'all. Physics with Beth and Beth. We're back. AP Physics 1 curriculum, Unit 4. We're almost halfway through the curriculum, so everybody can do a little happy dance. Pat yourselves on the back. You're doing awesome. We are still on collisions. This is our third video so far on collisions. And we are talking about a 2D collision now. Everything we've been talking about before, the carts were moving, or the cars, or any of the billiard balls, they were all moving in the same either horizontal or vertical. But now, just like how projectile, we did 2D motion with projectile, and they started moving horizontally and vertically at the same time. So what we're looking at here, we're going to have 2D collisions. We're going to have some east and north going on here. So we're going to, the very first thing you do in these problems, read them and then draw a before and after. I see a collision, so I already know I'm going to conservation of momentum. That's where you start, okay? So it's always good to know, where do I start? So I have a 550 kilogram car is traveling east at 15 meters per second. When it collides with a 950 kilogram truck that's traveling north, the car's going east, truck's going north, at 22, and that's 22.0, not 220. That would be a very fast truck, I mean. If the truck and the car collide and stick together, what is their final velocity and direction? All right, going to draw it out, very first thing. So I'm going to come over here. I have a before picture. I'm always going to do a before and then an after. Before, I have the car that is 550 kilograms. All right, and it is traveling 15 meters per second. Then I have the truck that is 950 kilograms, and it is traveling at 22 meters per second. I'll just put it up here, 22 meters per second. All right, now after, they are going to hit and collide. You have an east component and you have a north. So go figure, when they hit and collide, it says they will hit and stick together, and they want that final velocity and direction. Well, they're going east and they're going north. You've got momentum in both directions, so go figure, you're going to have, you're going to have a northeast. They're going to hit right here, and they're going to go off at a northeast velocity. Now you're like, oh, okay, I already have direction. It's northeast. No. In physics, it's not that easy. We don't want northeast. We want something more specific than northeast, because northeast can mean a whole lot of area. All right, so what they're really looking for is this theta. So you know what's coming. SOHCAHTOA. It's never going away this whole year. It's going to haunt you until you have nightmares about it. But anyway, all right, so here we go. We're going to get started. I'm going to do conservation of momentum. Momentum before equals momentum final. The momentum, I have two things moving. So here's the deal. You cannot combine these two anymore. Here is the concept behind 2D motion. Momentum is conserved in the x direction, and momentum is conserved in, actually, let me rewrite this over here so I have a little bit more room. Momentum in the x direction is conserved, and momentum in the y direction is conserved. Okay? So you can't combine x and y, just like in projectile motion. You could not combine the x and the y directions. Those are different. Things are happening differently. You have 15 meters per second of velocity in the east direction, horizontal, and the vertical, you have 22 meters per second, and you have different masses. So here we go. Initially, we're going to look at the x. Initially, the only thing moving horizontally here is the car. So that's the only momentum in the horizontal or x direction. And we're going to call that car, well, we'll just call it C, and we'll call the truck T. All right, so we're going to have m, mass of the car, velocity of the car initially, but then final, we have them stuck together. They are together. All right, so we have mass of the car plus mass of the truck times that final velocity, but not the hypotenuse, because we're in the horizontal. It's the final velocity in the x. So what we're actually going to be finding here is that final velocity in the x. All right, then In the y or vertical direction, we're going to be finding this final velocity in the y direction. And then guess what? In order to get the hypotenuse, we're going to use, we've turned this into a verb. We're going to Pythag it. We're going to use Pythagorean's theorem. A squared plus b squared is going to equal c squared. And that's how we're going to get that final velocity. All right, because part of that final velocity is in the x, and part or horizontal, and part of it's in the y or vertical. All right, so we already have it here. I'm just going to plug and chug now. We have our little final velocity. Actually, I'll go ahead and put it in an expression. We have the mass of the car, the velocity of the car initial, and I'm going to divide both sides by that mass of the car plus mass of the truck. And that's going to be my final velocity in the x. And that actually happens to be, well, let's put numbers in and then I'll show you. It's 550 times the initial, which was 15, divided by 550 for the car plus 950 mass in kilograms for the truck. And that final velocity in the x actually turns out to be 5.5 meters per second. So I can put that over here. It's 5.5 meters per second. All right, now we're going to do the same thing in the vertical direction, or the y direction. The only thing that had momentum before in the vertical was the truck. The car has no vertical component of momentum. It's only horizontal. So the truck is going to be mass of the, and I did put car, mass of the truck times the velocity of the truck initial. And after, same thing as this side. It's both of them stuck together, so mass of the car plus mass of the truck times that final velocity, not the hypotenuse, the final velocity in the y, because we are now doing the vertical or y direction. All right, I'm going to plug and chug now. Well, let me go ahead and solve with variables with an expression first over mass of the car plus mass of the truck. All I did was divide both sides by mass of the car plus mass of the truck. And that's going to equal your final velocity in the y. All right, so far so good, I hope. And now we're going to go ahead and put in our numbers. We're going to plug and chug now. Mass of the truck was 950. The truck was going 22 meters per second. The mass of the car is 550. The mass of the truck is 950. All right, that's going to equal final velocity in the y, and the final velocity in the y is, drum roll, 13.9 meters per second. Now, we have our x and our y. I'm going to go ahead over here and put it at 13.9 meters per second. Okay, now we have the horizontal component, we have the vertical component. We can Pythag this thing and do Pythagorean's theorem. C squared equals a squared plus b squared, right? Well, really, for us, it's final velocity squared, the whole, the hypotenuse, equals this final velocity in the x squared plus this final velocity in the y squared. I'm going to go ahead and just plug and chug now. In the x, it was 5.5, or horizontal. It was 5.5 meters per second squared. In the vertical, it was 13.9 squared. Don't forget to square those. And your v final, if you were to do that math, 5.5, 13.9, you get, I think, 15 meters per second. That is your hypotenuse. That is what they wanted to know. What was the velocity when those two stuck together? Now, yes, it is northeast. All right, but they want something better than that. Northeast covers a lot of territory. So I'm going to go ahead and just erase this over here. And I'm going to redraw this triangle. I have my 5.5 meters per second and my horizontal final velocity. This is final velocity in the x. And in the final velocity in the y, again, was 13.9 meters per second. I'm looking for theta. Now, I already also now have my final velocity here, my hypotenuse. So you could do sine, cosine, or tangent. Any of it works. I'm going to go ahead and just do tangent theta. The tangent theta is opposite over adjacent. So tan theta would be my final velocity, opposite, my final velocity vertical divided by my final velocity horizontal in the x. All right, I'm going to now plug in numbers. That's 13.9 divided by 5.5. And then I'm going to take tangent inverse of that, because remember, tangent's not a number. You can't divide by it. You have to take the inverse of it. It's a function. Tan inverse of 13.9 divided by 5.5. And you get that theta is 68 degrees. You now have magnitude of 15 meters per second for your final velocity. And you have the direction, because it is a vector. It needs magnitude and direction. All right, that's it. Hope that this helps on understanding 2D collisions. First of all, it's a collision. Start with conservation of momentum. Know that conservation of momentum is actually conserved vertically and horizontally, which I have erased. And you're going to find both of those components. Use Pythagorean's theorem, Pythag it, to get your final velocity, and then use either sine, cosine, or tangent at that point, because you have all three, to get your theta. Thank you for watching. If you like this video, please thumbs up it. And if you're watching our videos, we would love to see you subscribe so you can know that we've got new videos coming out, and we can know how many of you are out there watching. We'd appreciate that. And thank you again, and happy physicsing.